Algebra 2, lesson 2-3, example 6, write the equation of a parabola in factor form. This is the last example of this lesson. So write an equation of a parabola with x-intercepts at -2, 0 and -1, 0, and which passes through the point -3, 20. So for a linear equation, you would just need 2 points. But for a parabola, in order to be able to write an accurate equation, you would need at least 3 points. Okay, so we already have 3 points given. Given 3 points, are we able to write an equation? Yes, that is why we have this example. So the general form of a factored equation will be perfect for this given information. Okay, so first of all, we know that 2 of the points given are zeros of the function, right? Wait, no, these are y-intercepts. Yeah, so yeah, these are going to be zeros of the function, yes. So these two, where's my pen? These two are zeros of the function, right? So we already know it's going to be factored where you have a times a number times x minus p, where 1 is going to be -2, and x minus q, where 1 is going to be -1, right? Yeah. Why is it -p and -q? Because when your 0 is -2, then you probably have a factor of 0 of x plus 2, right? If you solve x plus 2 equals 0, you get a 0 of -2. So that's why this is the form, the general form of a factored equation. So remember this. And yes, the zeros are going to tell us the factors, but we don't know if this has an a, like another constant term that is multiplied to each factor, right? So first of all, we're going to substitute -1 and -2 for zeros. And then we're going to simplify, but we're going to substitute the third point in order to figure out a. This is why we need 3 points. 2 points of zeros can give us the factors, but the next point, another point is needed to give us more information about a, right? And so otherwise it's not going to be the exact same equation. There could be many different equations that you'll be able to have 2 points, right? So for example, you have these 2 points, but your parabola may look like this, or it may look like this, right? Or it may look like this. I don't know, right? So 2 points are not enough. You need at least 3 points. Maybe another point that goes here, then you know how far it's away from those 2 points. Or maybe like the third point is here. Still, you know how far it would be away. You know the trend line, right? So this is why we need 3 points. Anyway, so we're going to figure out a by plugging in the values for x and y here. So when x is -3, you plug in -3 for these x values, and then 20 for y here, and then you have just a left over to figure out. So solving for your equation, you will find out that a is 10, and now you substitute this a back into your equation, your general form, where we already know what p is, we already know what q is, but we just figured out a. So first of all, your first step again, you plug in the zeros of the function in the factored form, and then you solve for a using the third point, which should not be a 0 of the function. And then finally you plug in everything, a, p, and q, and you have the beautiful equation at the end. This is how you write the equation. Okay, so following these steps of writing the equation of a parabola in a factored form, you're going to write an equation of a parabola with x-intercepts at 3, 0 and -3, 0, which passes through the point 1, 2. So we also have 2 zeros of the function here, and so please use the same steps. Pause the video and come back when you're ready for answers. Okay, are we ready for answers? All right, so what's the first step? You write the general equation of the factored form. A times x minus p times x minus q. And then you plug in your zeros. Y is equal to a times x minus 3 times x plus 3, right? And then you plug in, substitute your last point, 1, 2, and figure out a. 2 is equal to a times 1 minus 3 and 1 plus 3. And so 2 is equal to a times negative 2 times 4. Negative 8a is equal to 2. So a is equal to negative 1 over 4. Okay, so now you just write everything all together, and y is equal to negative 1 over 4 times x plus 3 times x minus 3. And this is your factored form of a quadratic function, given those 3 points. If you want to write this in another form, you can use the same step and write down as a factored form first, because it's easiest to write the equation given equation in the factored form given 3 points, and then you can change your equation into another form. But this would be the steps when you have 3 given points. Okay, so that was try number 6 and the end of our lesson. So let's summarize our lesson. Factored form of a quadratic function would be a times x minus p times x minus q, right? The standard form can be written as a factored form like this, where p and q are the zeros of the function, and also the x-intercepts of the functions. Okay. All right, so that was lesson 2-3, factored form of a quadratic function. We'll continue with the next lesson in the next video. Bye.